Hello and welcome back to a new video in my Boost video series here on the Ludwig Fusel channel. In today's video we're gonna take a look at Boost.Asio. Now wait a minute before we get started. Didn't we last time worked with Align and should now talk about Any? No, Any is actually same than the SCD Any. The same goes for the array library. It's also the same than the SCD array, and these were kind of like implemented before the C++ features were a thing, like CPP 11 and CPP 3, so they were implemented before SCD Any and SCD array were things, so I don't want to talk about these. We want to go for modern Boost and for modern C++ versions, so we're going to continue on with Asio. Asio is a portable networking library for C++, so you can do TCP and UDP communication, you can do DNS, ICMP, there's like all of that network stuff in there. There's also a bit of abstractions about, in general, low-level I/O. I think there's also something that works with serial ports. I'm not sure. Yeah, there it is. Serial ports, file descriptors, and Windows handles. It's a bit in general like a low-level I/O and asynchronous I/O library. However, most of the time it's used for network code, so for TCP and UDP. So if you're writing an application that communicates over a network, I would highly recommend using Asio. Asio is available in a Boost and a non-Boost version, so if you don't have Boost, you can also watch the tutorial. The namespaces are different and the usage is also a bit different, but in the end the functions and the features are the same and they work the same, just that one works with the Boost primitives and the other one don't. They would just work with the standard library and with your plain code. Now, Boost.Asio would justify a whole independent tutorial mini-series, so completely independent of the video that we are doing today, so just about Asio. If you're interested in such a video series and you maybe want to get into how you can do synchronous, asynchronous I/O, TCP, UDP, how you can do TLS, so also encryption via OpenSSL, if you want to get some information on this, maybe write a comment that you want to watch a mini-series on that one, and if the comment gets enough likes, or if I'm just happen to be kind of like fond of doing such a tutorial series at some day, then I will do it, of course, and then we have a full video series. Today I just want to give you a kind of like an appetizer on Asio and just show you how easy you can do it by writing a simple UDP server and UDP client. So yeah, let's get started. I've already prepared, as always, a Visual Studio solution. It's still the same one, but a new project. And what we want to do is we want to include Asio. So I'm going to include Boost.Asio.hpp, and that's it. Now everything is known. Now in the end, what we are building is we are building a server and a client. So void server, that's one. And we're going to have a void client like that. So now we have a client into the server. I just want to quickly do some checks. So if argz is 2, so if we have 2 arguments, let's do a std string. Let's call this one app name, so the name of the application that we want to start, argv from 1, and this is then the app name, and then if the app name is equal to server, basically what I want to do is I want to call the server method. Else if, not a general else part, we can keep this one in though, so else if the app name equals client, then I am going to run the client, and then we can do a stdc out, an error message. I don't know, I'm not really a fan of std error, I never use it, kinda. But yeah, let's quickly include ourselves string and IOStream, IOStream, because that's what we need. And let's say usage is 0 for Asio server client, so that we a bit know what's going on. Alright, so this is basically our main function. We can collapse that, we are not interested in that. Let's take a look at the server and the client. Now, of course, you would want to write a portable way of writing applications and a flexible one. So I'm not going to do that, so what I'm going to define ourselves is I'm going to define ourselves the server as a constant. How is the server defined in Asio? So instead of the Boost.Asio namespace, there is the IP namespace and there's the UDP namespace, and an endpoint defines like an UDP endpoint. endpoint. Now, UDP communication is a connection-less communication. So basically, you are just sending data to a server to a specific port. So the endpoint has a IP address and a port. Now, UDP works like that. You are defining two endpoints for communication. One is the source endpoint and one is the destination endpoint. The source endpoint is the endpoint on your computer, and the destination endpoint is the endpoint on the remote computer that you are sending data to. This can be both the same system. That's not a problem. However, you need to define them somehow. I want to define the server endpoint just quickly in here. So I'm doing it like that. I'm using the constructor here of the server endpoint. And what I want to do is I want to specify the local IP address of the computer, so the link local address. You can do this by calling the Boost.Asio IP address from string function. Now basically I'm going to take a standard string and I'm converting that to an IP address. It's 127.0.0.1. This is the link local address. It always means like localhost, your local computer. And then what I'm going to specify is a port. Let's just use the port 5000, just any random port that is kind of like in the known numbers. If you're interested what the allowed port numbers are, I think it's like the maximum of a 16-bit integer -1, I think. And you should always not go lower than 1024, because these are kind of like reserved for well-known applications. So if you're writing something, take a high enough number. Alright, so now that we have the server endpoint defined, we do want to get started writing our server and our client code. Now what I'm going to use is I'm going to use Asynchronous I/O, because this is what Asio is known for. This is a bit more complicated than Synchronous I/O. However, I want to show you what Azure is up to. Now, the first thing that you need is you need to import the namespaces. I'm not a fan of using namespace globally, but inside of that function here, I'm fine with using the Asio namespace, and I'm fine with the Asio UDP. No, IP, UDP. No, it's not a private. How this should be a namespace. I don't know. Yeah, okay, let's just use the namespace Boost.Asio. It could be that UDP is actually a class. I don't know. In the end, just using namespace Asio, this is for now fine. Now, how do we create a server? Now, the first thing that we need for asynchronous I/O is we need an I/O context. The I/O context is used to run all I/O operations that we also need to call. So context is kind of like a queue. It is basically a queue, and when you're calling context run, it kind of like pulls the queue, executes the queue until the queue is finished and or empty, and then returns. So this is basically your very basic Asio boilerplate code that you always need. You always need the context, and you always need to at some point run context run. Now the nice thing on Asio and why it's so flexible is that you can actually call run from threads and from also multiple threads. So if you want to multi-thread your application that runs on Asio, you can basically just spawn as many threads as you want. Of course, it should be sensible and somehow reflecting the platform. So if you have an 8-core machine, maybe just spawn like 8 threads, and in each thread you can call the context.run function from the same context. Just create one context, create all your states of the application, then create your number of threads, and then call run multiple times on it. It's implemented in a thread safe way, so you can call run as much as you want, and then basically you have a producer-consumer principle, so you can produce from every thread into that context, and the context can be consumed by every thread to actually execute the work and poll if the work that's currently pending has been finished. So it's kind of like a queue. It pops from that queue, it checks if it has been finished. If it has been finished, it calls the handlers. If it has not been finished, it then queues it back again, and it does that until the queue is empty with the context.run. This is basically what happens behind. This is by far probably not an accurate explanation what's going on there, but in the end, this is doing all the work that we need. Now what we need to do is now write our code for the server and the client. Now the server and the client, they are both building around a so-called socket. So there's going to be an IP UDP socket. This is the basic class that we are using. We are using a socket for communication. Now the server socket, so the socket that we are using to receive data on the server, is of course being built up on the server endpoint. So what we are here specifying is we are specifying the context to basically tell the socket on which context to operate on. So every asynchronous operation that we are doing on this socket, this is going to be enqueued in the context, and this is going to be handled as soon as run starts working. So everything that we are doing that's going to be an async call on that server socket will not be executed directly. It will be enqueued, and then if context run is called at the end, it will be processed and kind of like waited for. So later on, we're going to receive some data on the server socket, and as soon as we are calling context.run, it will check if the work is finished. If it's not finished, it will wait. If it's then finished, it will kind of like call our handler, and then it will return because there's no more work and the server application stops. This is kind of like how it works. Now the server socket is constructed by the context and the endpoint. So context, so that we know where to work on, where to put our work, and the server endpoint, that we know what the socket is kind of like referring to. In this case, it's referring to the linked local address with that port number. This is what we are referring to. And this is basically now the point of view of that socket. And what we are doing on that socket is we are running the async receive function. What does async receive means? This means, first of all, async, it's an asynchronous operation, so enqueue it in the IO context and sometimes later poll it. Do not block until we receive data, make it asynchronously. Now, this is what async means. Receive is the operation that we are doing. Receive means, hey, listen to that socket and to that, receive means listen to that endpoint. So for that destination IP address on that port, listen if you are getting data there. And if we are getting data, then run some piece of code. In this case, async means the application can continue. Of course, it will then block if we are calling context.run because the context is running in the background. However, our application itself, the thread, is not blocked. We could use different functions on the context, the poll functions or the run one function that just runs like one work item and then goes off and does something else. So the general idea is that we are not depending on that function to directly return. It can return anytime it wants, and then it kind of like calls a handler. And I'm already talking about all of that stuff, and this is now what is kind of like coming into play. Now, first of all, what we need is we need some buffer to receive the data. I'm just going to take any arbitrary buffer, just a char buffer with 1024 characters in it. And what we need to do is we need to write the data into that buffer. Now, what we can do is we can construct this buffer. We can construct it with the buffer function here. It should be called buffer. Buffer should be some Asio type. There it is. This is the no buffer. Haha, yeah, that's the problem. Let's call this one data. Let's call this one data, though, that we can use the actual buffer class from Asio. Boost.Asio buffer. There is the buffer. Here is the buffer. I don't know why it did not detect that. Now it detects it. Then what we can specify is data, and we can specify the size. And now we basically have a destination buffer where our data is being written to. Now, what we need is, if we are asynchronously receiving on the socket, is a buffer, and we need a handler that's called when it's completed. I'm just going to do it as a lambda because this is going to make our things easy. And basically what will happen is that this lambda is called when data is received. Now, of course, this doesn't work like that. We need some parameters. So what are the parameters? We have an std error code. This is called EC in my case. And we are going to have a size t, and I'm going to call it bytes received. Now, this is basically the signature that we have. You have an error code that indicates if the async receive was successfully. If it was not successfully, the error code will kind of like reflect why it was not successfully. And if it was successfully, we also get an information how many bytes were received into that buffer. We had a maximum specified in here, 1024 bytes, but how many bytes did we actually get? So the bytes received here. Now what I want to do is I want to check if there is no error and that the length or the bytes received is bigger than 0. So if there's no error and no bytes received, then I want to do something. If this happens, I'm gonna just say error, so something went wrong here. We could print some error code, so we could say ec.message to also get information on what went wrong into that stream. That's also possible. Now, if we received, what I want to do is I want to make an std string. I'm going to call this string message, and the message is being constructed from the data and the bytes received, so that we know how long the string is. And then what I'm going to do is I'm just going to stdc out that. Actually, what we can do is we can get around with that. We don't need to save it like that. Let's quickly get ourselves a string view, and instead of putting that into a string, let's construct a string view out of that, out of the data and out of the bytes received. We can construct a string view, and then we can just print it like that, so that we kind of like print it as a string. So here received, then we have the string view and a end line. This is basically what I want to do when we asynchronously receive data. And that's already everything that we require for the server. Now, what we can now do is we can now implement the client. The client works a bit different. Now, first of all, we also gonna create a socket. So similar to how we have done it here. We also gonna create ourselves a socket. However, this is now a so-called client socket. The socket is constructed the same way. It's also constructed by a endpoint and a context. However, in this case, we need to construct the endpoint in a bit of a different way. So what I want to do is I want to create myself a default endpoint. So what you can do is you can just do it like that, IP UDP v4. This is kind of like your IPv4 address. And then you also need to specify a port. Since the port 5000 is already used by the server, we cannot use it as the client. So actually the client needs to have a different port, because the port 5000 is already open for receiving. So I'm going to take a different one for sending. I'm taking the port 0, which is like an invalid value, but it's not invalid because it's interpreted by the operating system as, just use any port that you like. So if I put in 0, the operating system will choose the port that's available. And basically means we don't care which port, just give me any free port for sending. We don't care. We can send from every port that we want. If you have a more defined communication and you actually are keen on getting it from a certain point, a certain port, then of course you could also specify a port here that you're using for sending. Sometimes this is a thing that sending and receiving it works over a well-defined structure of ports that you definitely know the source and the destination port. But in this case, we can just say 0 and call it a day. So basically this socket is now any UDP socket on my IPv4 address with any port you like. We need it in that way to send the data. We need a socket to send data from. Now this is now any socket on our IP address with any port. So we don't really care about, because we are just using the socket for sending. And this is exactly what we want to do. We want to send something. Let's make a std string message. So the message is going to be hello world is what we're going to send over the lines. And yeah, that's basically what I'm going to do. I'm going to do a async send to. So the async send to now needs to specify another buffer. So I'm going to specify a buffer with my message.data and my message.size, so that we can get the information out of that. Then because we are using the async send to function, we need to have a destination. So where do we want to send the data? We want to send the data to our server endpoints, so the one that we used in the server for creating the listening socket. We want to send to that exact socket. So I'm specifying the socket here. And since we are on an asynchronous function, we also need a completion handler. The completion handler is also going to have an std error code EC, and it's also going to have an error code send bytes. So we're going to have an error code and an information on how many bytes we sent. So let's check if not EC and send bytes is bigger than 0. I'm just going to be stdc out, and I'm going to say send bytes, and then I'm going to say bytes send successfully. Okay, std and then if there was an error, we can basically just copy and paste our error handling code from here to there, and that's it. We are finished with our code. Let's quickly hit Ctrl+Shift+B to compile the code. I hope it compiles so that I didn't make any mistake. Yeah, it compiles. This looks good. And then let's actually start and try out with our code. Now, I'm going to jump inside of Visual Studio Code. And what I'm going to do is I'm going to navigate to my build folder. So here on the left, I'm going to go to build x68 _64-debug. binary. This is the directory where all of my binaries are, including the 04asio.exe. And what I can do is I can right-click this and say open an integrated terminal. So now basically I have a CMD that's in that folder. And what I can do now from here is I can start the server or even the client. I could start server or client. If I just enter the name, I get nothing. Why do I get nothing? Why do I get nothing if I call 04asio.exe? I should get a message. I should get this one. Yeah, because, okay, yeah, straight, true. Let's move this piece of code to down here and just hit a return 0 everywhere. I'm not sure if I use one return, if I need to have a well-defined return path. No, it works like that. So just return 0 here, and then if there's some misuse, I'm doing it like that. Okay, so if I run that, I should now get a usage. Now what I can do is I can run the client, and you can actually see if I run the client that bytes were sent successfully. However, if I run the server like that, you can see that our application is blocking. Now why is our application blocking? Well, because there's some task in that IO context. There's a task of receiving some data. However, we are not receiving data currently. So what I need to do is I need to open up another terminal. So I'm going to again open an integrated terminal. So I now have two terminals. Maybe can I put them side by side? Is that possible? I can at least put them like that. You can see the server is now running at the bottom here, while at the top I have an empty CMD. So I can now go again for Asio, and now I'm going to client. And if I enter client, you can see 12 bytes sent successfully. And here at the bottom, you can see received hello world. So now basically what we have done, the client has sent hello world to the server. One very important thing, the client can send however it wants. It doesn't really care if the data is coming to the server or not, because we are using UDP. And the server on UDP, it's just listening. It could be coming from every application. If you have some socket tester or something, it works. You can send data here. I could even try, I'm not sure, can we do a quick port ping? Let's create a quickly new PowerShell script here that ChatGPT generated, and let's run it. The port is 5001. Is that the right address? I'm always struggling with the UDP addresses sometimes. With the link local, I sometimes mix up the numbers. Yeah, I was thinking about that. And if I run that, okay, so you can see actually the UDP packet was sent. Even through we get some error message. And if I would take a look at my server and start my server here and just send this arbitrary UDP data, you can actually see that hello was sent. Did they really send hello? That's interesting. Where is the hello? Oh, actually, there's a message. Lel. I've just made myself a UDP client with PowerShell. Yeah. I didn't want it to go that far. But in the end, yeah, you can see it works, right? That's the whole story about it. Yeah. Quick introduction to Boost.Asio. I tried to be as fast as possible, but Boost.Asio is a big library. If you want to have a proper tutorial on network programming, just ask me up. We can do it. So then, thank you for watching. See you in the next video where we are going to explore the next Boost library. Until then, have a nice day. Bye.